In order to affect the future profoundly, a time traveler would have to pick and choose. He'd probably have to intervene in a number of events which are very carefully selected, so he could change the weave of history. It's a lovely fantasy to explore those other worlds that never were.
If you had H.G. Wells's time machine, maybe you could understand how history really works. If an apparently pivotal person had never lived, Paul the Apostle or Peter the Great or Pythagoras, how different would the world really be?
What if the scientific tradition of the ancient Ionian Greeks had prospered and flourished? It would have required many social factors of the time to have been different, including the common feeling that slavery was right and natural. But what if that light that had dawned on the Eastern Mediterranean some 2,500 years ago had not flickered out? What if the scientific method and experiment had been vigorously pursued 2,000 years before the Industrial Revolution, our Industrial Revolution? What if the power of this new mode of thought, the scientific method, had been generally appreciated? I think we might have saved 10 or 20 centuries. Perhaps the contributions that Leonardo made would have been made 1,000 years earlier, and the contributions of Einstein 500 years ago. Not that it would have been those people who would have made those contributions, because they live only in our timeline. If the Ionians had won, we might by now, I think, be going to the stars. We might at this moment have the first survey ships returning with astonishing results from Alpha Centauri and Barnard Star, Sirius and Tau Ceti. There would now be great fleets of interstellar transports being constructed in Earth orbit. Small unmanned survey ships, liners for immigrants, perhaps. Great trading ships to ply the spaces between the stars. On all these ships, there would be symbols and inscriptions on the sides. The inscriptions, if we look closely, would be written in Greek. The symbol, perhaps, would be the dodecahedron. And the inscription on the sides of the ships to the stars, something like Starship Theodorus of the planet Earth.
If you were a really ambitious time traveler, you might not dally with human history or even pause to examine the evolution of life on Earth. Instead, you would journey back to witness the origin of our solar system from the gas and dust between the stars. 5 billion years ago, an interstellar cloud was collapsing to form our solar system. Most clumps of matter gravitated towards the center and were destined to form the sun. Smaller peripheral clumps would become the planets. Long ago, there was a kind of natural selection among the worlds. Those on highly elliptical orbits tended to collide and be destroyed, but planets in circular orbits tended to survive. But if events had been only a little different, the Earth would never have formed, and some other planet at some other distance from the sun would be around. We owe the existence of our world to random collisions in a long-vanished cloud. Soon, the central mass became very hot. Thermonuclear reactions were initiated, and the sun turned on, flooding the solar system with light. But the growing smaller lumps would never achieve such high temperatures and would never generate thermonuclear reactions. They would become the Earth and the other planets, heated not from within, but mainly by the distant sun. The accretion continued until almost all the gas and dust and small worldlets were swept up by the surviving planets. our time traveler would witness the collisions that made the worlds. Except for the comets and asteroids, the chaos of the early solar system was reduced to a remarkable simplicity. 9 or so principal planets in almost circular orbits and a few dozen moons. Now, let's take a different look. If we view the solar system edge on and move the sun off screen to the left, we see that the small terrestrial planets, the ones about as massive as the Earth, tend to be close to the sun. The big Jupiter-like planets tend to be much further from the sun. But is that the way it has to be? Computer studies suggest that there may be many similar systems about other stars, with the terrestrials in close and the Jovian planets further away. But some systems might have Jovians and terrestrials mixed together. There may be great worlds like Jupiter looming in other skies. Rarely, the Jovian planets may form close to the star, the terrestrials trailing away towards interstellar space. Our familiar arrangement of planets is only one, perhaps typical, case in the vast expanse of systems. Often, one fledgling planet accumulates so much gas and dust that thermonuclear reactions do occur. It becomes a second sun. A binary star system is formed. For most of these worlds, the vistas will be dazzling. Not a one of them will be identical to the Earth. A few will be hospitable. Many will appear hostile. Where there are 2 suns in the sky, every object will cast 2 shadows. What wonders are waiting for us on the planets of the nearby stars? Are there radically different kinds of worlds, unimaginably exotic forms of life? Perhaps in another century or 2, when our solar system is all explored, we will also have put our own planet in order. Then we will set sail for the stars and the beckoning worlds around them. In that day, our machines and our descendants, approaching the speed of light, will skim the light years, leaping ahead through time, seeking new worlds. Einstein has shown us that it's possible. We will journey simultaneously to distant planets and to the far future. Some worlds, like this one, will look out onto a vast gaseous nebula, the remains of a star that once was and is no longer. In all those skies, rich and distant and exotic constellations, there may be a faint yellow star, perhaps barely visible to the naked eye, perhaps seen only through the telescope. The home star of a fleet of interstellar transports exploring this tiny region of the great Milky Way galaxy. The themes of space and time are intertwined. Worlds and stars, like people, are born, live, and die. The lifetime of a human being is measured in decades, but the lifetime of the sun is 100 million times longer. Matter is much older than life. Billions of years before the sun and Earth even formed, atoms were being synthesized in the insides of hot stars and then returned to space when the stars blew themselves up. Newly formed planets were made of this stellar debris. The Earth and every living thing are made of star stuff. But how slowly, in our human perspective, life evolved, from the molecules of the early oceans to the first bacteria.